Week 1 in physics and chemistry is on measurement, so let me show you a few things that we had for the lab. This is a very coarse device for our purposes. Already at this point you're at 1 pound, and we tend to not need so heavy items. So this is only good for showing how imprecise an instrument can be, I suppose. Here's a triple balance beam that you might find at another school or university. They tend to be getting rid of these. And finally, I have a 2-pan balance my friend gave me. I think he found it at a flea market. It might have belonged to an apothecary 100 years ago. So it has this little tray here for the weights you can put on this side, and then you put the object over here. And there's something, you hang a string from this thing down to there, and if it hits the point, then it should be level. So there's a leveling system. If I can find my plumb line, then I can make that work. Or you can just use a bubble level to get it all level. All right, so we use these things to measure weight. To measure distance, I have a set of calipers. And so this just, you slide this down, and these will be the outside calipers. These are inside calipers. So if you wanted to measure the inside of this graduated cylinder, you'd put this in here, and then you could stretch it till it, and then then you read off how wide that is. Okay. Or with these balls, you'd need the outside calipers, and you put the ball in between there. Okay, so this is very precise because of the dial. You look at over here to figure out about approximately the length, and then on the dial will tell you an extra digit of accuracy. Okay. Similar to the calipers is a micrometer. The difference is mostly that the micrometer has an anvil. So if you're measuring something like a diameter, then you don't have to be as concerned about getting a chord instead of, so you put a sphere in there, and that's necessarily going to be the diameter, and because of this flat surface will catch the very extreme point. Okay, so this is better for measuring diameters of spheres and circles. I have a bunch of spheres and these cylinders made of different kinds of metal. So we calculated in physics. We found weights and lengths of things. I had a bike tire, because I bike to school every day. I brought my front tire in, and they were supposed to measure the tire pressure. I should have brought a better pressure gauge, so that failed. And I think they should know how to do that, especially if they're going to be driving. Okay, so if you can measure length and weight, then you can start measuring density. You want to measure volume as well. So we have a graduated cylinder here. Make sure if you have something metal or heavy that you're using plastic. I had a glass one, and it broke. So if you want to measure the volume, you put some water in, and then slide this in and see how the water rises. So by an Archimedean principle, the difference would be the volume of the cylinder, and then you get densities. I had a chart of the different densities for these metals, and the objective was to figure out which metal was which. So this one looks obviously like copper. I believe this is brass and aluminum. It's the light one, and I think this might be nickel. All right. So in chemistry, we used this little tiny flask. It's a 5 milliliter flask, and it's quite nice because you fill it up, and then you push this in. There's a little straw right here, so the excess liquid comes up, and if you wipe it off, then you'll have extremely close to exactly 5 milliliters. So what we did, we measured the density of salt water. I prepared some salt water. It takes quite a lot of salt to saturate just distilled water, and so we measured the density of water. Water should be exactly 1 gram per milliliter because the metric system is made to be nice. So we measured the density of water, and they got 0.995 or something. And then we measured the density of salt water, and I think it was 1.22. So you can talk about the density of maybe talk about the Dead Sea and how you can float on it, and just it's just having this fun little device to get, because that's the most precise instrument in my lab. So, all right, that's what I have for this first week of labs. Thanks.